Hello, this is a brief description of an adaptation of anaerobic biodigester technology for small remote communities who have experienced damage to their soils from wind erosion, and especially addressing those communities that have over-harvested trees in the region for their firewood. We have designed and built systems as small as 400-liter capacities and as large as 8 million liters. Anaerobic biodigesters combine heat, which we are currently operating systems utilizing solar heat, with water, and this doesn't have to be of drinking quality, and organic material. Our system uses garden and food waste, and occasionally manure, and all of this is contained in an airtight tank. The result is methane gas to replace wood for cooking, and liquid fertilizer that activates composting and enriches soils to grow food and improve diet. As we look at the actual construction, it begins with preparing the site foundation by digging shallow holes. The primary component are two steel 55-gallon drums welded together to be airtight. The tank is fitted with a loading pipe to pour in either food waste or manure, diluted with water. Before welding the two drums together, they are fitted with flow baffles that assist in isolating solids or particulate and prevent clogging. This is an important consideration for small biodigester systems, where dilution and flow are not as critical an issue in larger systems. It can be managed in small systems with proper construction and operation methods. A drain pipe used to completely empty the tank, while it may be used at some point, it can be considered optional. Every time you fill the tank with 15 liters of feedstock mix, 15 liters of 30-day aged, odorless digestate comes out the other end. At the same time, the microbiology in the upper space in the tank is producing methane gas, and this is connected with a pipe or hose to a variety of types of collection systems. One method is to use a 50-gallon drum filled partially with water, with a 30-gallon drum inverted and fixed inside the 50-gallon drum. The result is a water-sealed gas storage, using hydrostatic pressure to transfer the gas for use. Another method is to use a sealed bladder or bag, either fabricated or purchased. One of the several advantages to this method is the gas can be transported for use beyond the length of the gas supply line. It can also be relocated easier and replaced by larger bladders. Methane gas, while producing a hot flame, is very stable to use and requires very few extra considerations. However, its molecular structure requires quite a bit of energy to compress. So for the most part, large or small, almost all biodigesters store gas like this at atmospheric pressure. Relying on the sun to heat the digester requires that a portion of the tank is insulated to retain the heat at night and stabilize the heat in general. We use typical polypropylene feed sacks filled with the dirt we use to excavate our holes in the first step. The sacks underneath to support the tank we leave with spacing to encourage warm air circulation. The sides of the tanks have these stacked in a wall that follows a general contour of the tank shape, also with airspace to allow warm air to circulate around the tank. We close in the ends of our insulation containment with full or partially full sacks to accommodate the shapes of the pipes and allow them to come through. The southern side of the feed sack walls is left partially open to allow sun to heat a portion of the metal drums we've constructed as a tank. The steel of the tank is very efficient in distributing the heat to the areas not exposed to the sun. The air spacing we've left between the dirt-filled sacks and the tank contribute to creating a subtle thermosiphon. To increase the heat contained in our dirt sack container, a semi-transparent cover is created using braces and a piece of plain polyethylene sheet. The braces can be made with scrap wood or even small branches. The polyethylene sheeting can be cut from a roll or by repurposing an old sheet. Obviously, the clearer the better, but not required. The plastic cover is secured to seal off the tank as completely as possible. Stiff wire bent into a U-shape or even just rocks can accomplish this. When we first start the digester operating, we use what is called inoculum to get the process started. And typically this comes from a biodigester already in operation. The amount of time before methane gas is created can vary depending on the amount of inoculum we add to the tank when starting it up. The digestate or liquid fertilizer needs 20 to 30 days to be created, but after that it is continually available to use to combine with food scraps and grass in those shallow pits we dug. Once that first growing medium is ready for planting, then you grow beans, peas, or other legume plants. And after one growing season of that, you plant your other choices for feeding your family. The ultimate goal might be to eventually overproduce food in your garden to feed directly back into your biodigester, increasing the methane gas production for cooking fires, feeding others in your community, or both. This has been a very brief overview of how the TerraDesic biodigester might help Ugandan communities, or communities in other countries. The larger discussion is how to refine the design and operations to work with the realities of the culture, society, and people this project intends to serve. Thank you for watching.